Okay, guys, this is Worm from Worm's Maths Academy, just running through the 2018 Northern Hemisphere multiple choice section of the Northern Hemisphere Methods Exam 2. I just made a big cock up of what I said, but anyway, okay, first question. Period. We know period is 2 pi on n, which is pi on 4. Of course, that's just 8. And our range, our center, is 3. We go up to and down to. It's for all real numbers, so we don't need to worry about the whether or not the whole graph is completed. It completes at least a cycle. So 5 down to 1, 8, 1 to 5. Okay, the graph shows part of the polynomial function. Okay, we've got a repeated factor, so x plus 2 squared. We've got an x minus 1, and we have an x minus 3. However, the graph goes down to the right, so one of them has to be negative. So I put a negative out the front. Okay, we need x plus 2 squared, so I can get rid of all of them. Okay, the first one, x plus 2, x minus 1, that isn't negative. So it's got to be one of these. Can't be that. Oh, can it? X plus 2. It is that one. X plus 2, x minus 1, 3 minus x. If I multiply that negative in, this bracket becomes 3 minus x. So our second answer is C. Discrete random variable has a binomial distribution with a mean of 3.6 and a variance 1.98. N and P. Okay, so we know NP, because it's our expected value, is 3.6, and our variance is NP 1 minus P. That equals 1.98. Okay, if we do 2 divided by 1, they're going to cancel. So I get 1 minus P equals 1.98 on 3.6. Okay, 1 minus x equals 1.98 divided by 3.6. Solve for x. Okay, so P is 9 on 20. So if P is 9 on 20, we know that NP equals 3.6. So if I do 3.6 divided by 9 on 20, I get 8. So N is 8. P is 9 on 20. That's D. Sample space such as A is B, A or B. Okay, so A or B, that's the probability of A naught intersects B naught. 1 minus that. That's equal to 1 minus probability of A or B. So that's going to be 0.3. So if we create a table, A naught, B naught. A is 0.6. That's 0.4. B is 0.3. That's 0.3. A intersects B naught. A intersects B naught. Okay, so that's got to be 0.7, which means that's got to be 0.4. A intersects B naught is 0.4. Okay, set of 3 numbers. It could be a solution. Could be solutions to that. Okay, x cubed plus ax squared plus 16x plus 84. Okay, so the 3 numbers have to multiply to give 84. Okay, 3, 12, 7 to 84, 84, 2 ones, 2, can't be that. 2 sixes are 12. Okay, so it could be that. Could be that. Okay, we want to end up with a positive at the end. Okay, can't be that, because if I had x minus 2, x minus 6, x minus 7, that would make it positive, but then that would make it negative. So it can't be that, which means it can't be that as well. Okay, here I'd have x plus 4, x plus 3, x minus 7. So that would end up with a negative 84. So the only answer it can be is D. Find the sum of the solutions. Okay, I'm going to say this one's much easier to do by cos. So sine 2x on cos 2x equals negative 3 on root 3 between 0 and 2 pi. So tan 2x make sure it's in radians. Tan 2x equals negative 3 divided by root 3. Solve, but I want it between 2 pi. Okay, the sum of the solutions plus 13 pi on 3, which is D for number 6. 6 balls number 1 to 6 placed in a jar. A ball is taken randomly from the jar, and it's recorded. This ball is then returned to the jar. Second ball is in randomly, and its number is recorded. The sum of the two numbers is then calculated. Find the probability that the sum of the two recorded numbers is 7, given the first number is odd. Okay, so I can get a 1 and a 6. I can get a 3 and a 4. And I can get a 5 and a 2. The probability of the first number being odd is 3 out of 6, which is a half. And then the probability of the first number being odd and adding up to 7 is 3 out of 36. So the probability that it adds to 7, given that the first number recorded is odd, is 3 on 36 divided by a half, which is times 2, which is 6 on 36, which is 1 on 6. We're trying to go reasonably quickly, remember? Okay, the graph of f dash of x is best represented by, so I've got negative gradient, negative gradient, negative gradient, infinite gradient, negative, 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 negative. Okay, so we've got to have negative getting to negative infinity, and then get negative going back to 0. So because it's negative, can't be that because we want no positive values at all. It's got to be that one. Negative, 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 going to negative infinity, and then back up to approaching infinity. Continuous random variable has a distribution mean 40, standard deviation of 5. Okay, so whenever you have a question like this, always draw 40, 45, 50, 55, 35, 30, and 25. And we know that's 0, 1, 2, 3, negative 1, negative 2, negative 3. Okay, so negative 2 to 1, negative 2 to 1 would be 30 to 45. Okay, it could be this one, but I don't think it is. I think what they're trying to get you to do is see negative 2 to 1 is the same as negative 1 to 2, which is 35 to 50. So it is B, number 9. Okay. Let's have a look. the range of this function between negative 1 on root 2 on root 2, 2x cubed minus 3x plus 4. 2x cubed plus 4. And then we want to say given negative 1 on root 2 is less than x, is less than x, which is less than, what was the other value? Root 2. Okay, sketch it. Okay, so analysis G solve. Okay, we know the left-hand side and then the minimum. So we can go outside, edit, copy, paste. So we say given x equals negative 1 divided by root 2. So that's our lowest value. And our minimum value, let's say it's between 0 and 1, calculation f min 0 to 1. Okay. So what does the question ask? That's our maximum value, and that's our minimum value, root 2 plus 4. But it was a root 2 plus 4. Yeah, this one, I think. Let's have a look. So the minimum value is negative root 2 plus 4, but that's inclusive, so it can't be that one. Root 2 plus 4 to 4 plus root 2. I don't think we got that as the maximum. So 4 plus root 2, what's at the other end? X equals root 2. Okay, so it's the same value at both ends. So that's right, the maximal domain of the function where that, okay, we know that negative 2x has to be greater than 0. So we know that x has to be less than 0. Can't be equal to 0, so it's all real negative numbers. Nice easy one. The average value from 1 to a is 3 on 13. Okay, so that means 1 on a minus 1, 1 to a, x squared minus 2x dx is 3 on 13 on 3. Okay, so 1 divided by 1 minus, we'll say y, from 1 to y of x squared minus 2x, x squared minus 2x dx. Remember to push your right arrow, equals 13 divided by 3. Interactive advanced solve, and we want to solve for y. No solution. Okay, what have I stuffed up? 1, y minus 1. Okay, y equals negative 3 or 5. It's got to be positive. So it's going to be 5 because a is greater than 1. Okay, the property has a function f of 2x equals... okay. So I'm going to put judge in my calculator, f of 2x, f of x squared minus 2. So what I do is I define the first function. So 1 on x squared plus 4. So interactive define 1 on x squared plus 4. Okay, then we go into judge, J for judge. F of 2x equals f of x all squared, and then minus 2, and then hit enter, undefined. So what was the next one? Cos x. So cos x, hit enter, false. It's going to be the last one for sure. 2 log e x squared, 2 natural log was it x squared plus something? X squared plus 1. X squared plus 1, undefined. E to the x plus e to the minus x. E to the x plus e to the minus x. True. Okay, so we've got a winner. D. Okay, the graph of the function is obtained by a dilation of factor half from the x-axis. So we half from the x-axis, it's going to be half cos x minus pi on 6. Reflection in the y-axis, so a half cos minus x minus pi on 6. Translation of pi on 6 units in the negative x direction. So half cos negative x plus pi on 6 minus pi on 6. And 4 units in the negative y direction in that order. Okay, so I've got a half cos negative x minus 2 pi on 6, which is minus pi on 3, and then plus negative y direction, so minus 4. I forgot the 3 out the front, didn't even see that. 3 on 2, 3 on 2, 3 on 2, minus x minus pi on 3. 14a looks good to me. Okay, if we integrate from negative 3 to 2, we get negative 8. So from negative 3 to 2 is negative 8. 2 to 3 is 10. So we're just going to get 2. That one's pretty easy. The terminals aren't swapped or anything. The domain and range of f of g of x is respectively f of g of x. So f of x, f, domain, range, f is greater than or equal, or greater than 0, and that is from, that's negative, so it's flipped upside down, but it's all reals, I should say. Okay, that is x squared plus 1. So x is an element of R, and then my range is greater than or equal to 1. So we're putting that into that. So the range g of x, that fits into that. So your domain is all reals. And then the range of that function is the range of negative log e x squared plus 1. So let's have a look and see what that is. Okay, so that's going to be less than or equal to 0. Analysis g solve max 0, 0. So R minus or 0 and all reals e 16 e. Okay, f of x is an antiderivative of f of x. F of 4 is negative 6. F of 8 is equal to. Okay, so we know that when we integrate from 4 to x, it would equal dx. It's going to equal negative 6. So then this one is going to be from 4 to 8 f of x dx minus 6, which is e. Special kids will know that. Not too sure about methods kids. Yeah, it's a bit funky. Okay, the graph below, which have the same scale. Okay, so it's been moved 3 to the left. It's been moved, it's been reflected in the y-axis. Reflected in the y, which have the same scale. Okay, so it's been reflected in the x-axis, not the y-axis. So that's reflected in the x-axis, reflected in the x-axis. It looks like it's further away, but it's really hard to tell. How would we know for sure? See here, that space in there. Okay, I'm going to say it's really hard to know. Which have the same scale. F onto the graph of G. I mean, it's definitely further away. But they've drawn it like it's not. Because if you draw this area in here, that area is bigger than that area in there. So it should have been dilated from an axis. Okay, so if we move it 3 to the left, that would bring it to there. If we reflect it in the y-axis, that would bring it to there. So I'm thinking that our answer is C. Hang on. Could they have done, if you reflect it in the y-axis, because it looks like it's further away, so it wouldn't make sense. So if you reflect it in the y-axis, that, and that would be the same. So you reflect it across, then reflect it in the x-axis, and then if you dilate it by 2 from the y-axis, which is this one here. So it isn't actually translated at all by the looks of it. I actually think it's been dilated from the y-axis because that area, those two areas don't match up. That area there and that area there, they're two different ones, so I reckon it's going to be D. Okay, a box contains 20,000 marbles, either blue or red. There are more blue marbles and red marbles. Samples of 100 marbles taken from the box. Each sample is obtained by sampling with replacement. If the standard deviation of the sampling portion of marbles is 0.03, then the number of blue marbles in the box is random samples of the standard sampling distribution for the proportion of blue balls, standard deviation for the proportion of blue balls. Each sample obtained by sampling with the present proportion of blue balls is 0.03. Okay, so P, 1 minus P on N is equal to 0.03. Standard deviation of the sampling distribution for the proportion of blue balls, and the number of blue balls in the box is. Okay, so 100 random sample, proportion of blue marble, sampling distribution. Okay, so it's sampling. So let's say on 100, Okay, so if I square the other side, I'm going to get P, 1 minus P, equals on N, 0.009. N is 100, so times it by 100. So we'd get P, 1 minus P, equals 0.9. Okay. X, 1 minus X equals 0.9. Interactive with that. Solve P. (0.3 squared times 100). Is it 0.03 or 0.3? 0.03. Okay, so it's 9 on 100. So it's X, 1 minus X, for the times in between, equals 0.09. Solve for, okay, so X equals 1 on 10 or 9 on 10. Okay, there's more blue balls. So P must be 0.9 because it can't equal, there's more blue balls, so the proportion has to be higher for blue balls. And if it's 0.9 times 20,000, it's going to be 18,000 because 0.9 times 20,000 is 18. Let one be a one-to-one differentiable function such that f of 3 equals 7, f of, okay, so this is f. F of 3, this thing equals 7, and f of 7 equals 8. F dash of 3 is 2, so it's positive. F dash of 7 is 3, so it's steeper. F is differentiable, and g of x equals f inverse of x for all x. Okay, so g of x is f inverse of x. Okay, so let's think about it. We're going to swap all the points. So that will become 7, 3, 7, 3, and that will become 8, 7, 3, 8, 7, 7, 3, and then 8, 7. Oh, I haven't done the scale properly. F dash of 3 is 2, so g dash of 7. So g of x is basically the inverse of this function. So if f dash of 7 is 3, that's there, then if you draw its inverse, it's going to be 1/3. G dash of 7, the derivative, let's try again. Okay. G of x is f inverse of x. Let's go back to the other color. Okay, so f of 3 is equal to 7, and we know f dash of 3 is equal to 2. So g of 7 is equal to 3. G dash of 7 is equal to 1/2, which is A. I just had the stupid things around the wrong way. So, 1/2. I looked at the wrong things here. So it's definitely a half. Okay, hopefully I haven't stuffed any of them up. I did try to go